Okay. Fortunately, I'm still feeling sick from COVID, but let's see what we can have to do. What we can do today. Okay, we did those tech ones. Oh, I have to repeat what I did, but without a calculator. No. All right. 237. Okay. Oh dear, my head. Okay. What will we get first now? Increasing or decreasing? Right. Well, the derivative is the product rule, so that would be cos x um, sin x ex plus sin x ex. I can take the ex out. I want this to be positive, which means I want sin x to be more than minus cos x, and provided that cos x is not 0, then we want tan x to be more than minus tan x. No, hang on, I'll leave the minus on the right. So you want tan x to be more than minus 1. That's when it's increasing. So we could solve for when tan x equals minus 1, which is 135 degrees. We want to put that into radian mode though. I just think about the tan x graph actually. Oh, it's only over minus pi to pi, so let's see, that tan is, okay, let's just say that's pi there, and then that's minus pi, and that breaks to infinity, so it goes like this, and then breaks to infinity. So increasing, let's see now, that's when tan x is more than minus 1. So let's just put a minus 1 line in here. So that would be from here, which is minus pi over 4. And then that's up to pi over 2. Then pi over 2 up to pi, right? Well, no, not quite, because pi over, I think because where I drew my minus 1 line is confusing me a bit. I think I'll just change my graphic a little bit. Okay, there's the pi over 2 asymptote. And then we'll just put minus 1, like, make it a little bit higher, a little bit higher. There we go. All right, so I'm still happy with what I said at the beginning, minus pi, it's all above -1, but not here, because when it crosses pi/2, it's coming from -infinity, so it's only up until pi/2, and then it's not picking it up again until -pi/4, and up until pi/2, and then 3/4 pi to pi. That's when it's increasing. So decreasing is everything outside of that. So that would be the pi/2. Sorry, I should have minus pi/2, -pi/2 to -pi/4, and then pi/2 to 3/4 pi. Okay, B. Max and min is when this is equal to 0, so that would be at minus pi/4 and at 3 pi/4. Could I roughly sketch this to figure out which is which? Sine 0 is 0, so I guess it's going to go like kind of like this. So I'm guessing this one is the minimum and this one is a maximum, without having to do more work than I need to. Concave up and concave down. I need to look at the second derivative. Okay, so the second derivative, so that would be cos plus sine. Well, cos becomes minus sine, and sine becomes cos. So it just ends up being cos minus sine ex plus the same thing, cos x plus sine x ex. But I guess what's nice here is that the sines cancel out, so it's going to be 2 cos x ex. But if you're only looking at the signs, if it's positive or negative, you just care about the cos x. So when is cos x positive? Or actually, which one do we want first? We want concave up. Concave up will be, yeah, cos x positive. So if I just think about the cos graph, but only going up to pi, so concave up would be from minus pi over 2 to pi/2, and then concave down would be minus pi to minus pi/2, and then pi/2 pi, and the inflection point, I can squeeze it in here. Inflection point is when this would be 0, which happens at pi/2 and minus pi/2. That's the inflection points for part D. Okay. Let's have a look at that answer at the back. The only one I'm not really sure about is the maximum. I guess I could check it here. So if you put in minus pi/4 into this, you'll get a positive, which makes it a min. And if you put 3/4, that's still a positive, isn't it? No, it's negative, which makes it a max. So I think I'm right. Let's check the answer for 237. increasing from, okay, let's see, increasing from minus pi over 4 to 3/4 pi. They have increasing only within this interval here and decreasing otherwise. Our min and max are correct. Concave up and concave down. Concave up. So where's concave up? Yeah, concave up and then concave down is outside it then, and the inflection points. Yeah, it's just the increasing. Increasing from minus pi over 4 to 3/4 pi. Must have been something to do with me not fully considering this. Let's check the answer on a graph. If I can get it. Sine x dx. So sine x ex. Oops. I want there. Okay. So they're saying increasing from minus pi over 4 to 3/4 pi. How does that differ to what I said? I said increasing from minus pi to minus pi over 2. Minus pi to minus pi over 2. I said increasing from minus pi. It's tan of minus pi. Am I wrong here? It's 0. I've done something wrong with the first part now. Because I can see decreasing, then here doesn't start increasing until about here. That's minus pi over 4. Minus pi over 4 to pi over 2. But I'm wrong with the extra piece then here. Then it's increasing up until here. just 3/4 pi. Okay, so I'm doing something wrong here. That's me. That's me. So let's correct that. Okay, so you want this to be 0. So that means you want cos x plus sine x to be positive. Which means we want sine x to be more than minus cos x. Which means you want tan x to be more than minus 1. Yeah, and that's so that, yeah. Again, if I just draw the graph here, so tan x is more than minus 1. So all the way to here, but not after pi over 2. But that doesn't match up with the other graph though. So the other graph here, it's decreasing, even though tan is more than minus 1. So I must have something wrong with my derivative. I do have something wrong. I made a sign mistake, didn't I? No, I don't. Did I make derivative of sine is cos? And then no, that is right. So what on earth is happening here? This is very peculiar. So it's increasing when this is positive. Oh, no, I see my mistake. Silly Stephen. I can't divide by cos unless I know that cos is positive. What a schoolboy error. This is harder to solve than it looks, I'm afraid, if I go over here. So we'll have cos x plus sine x more than 0. Sine x more than minus cos x. Can't divide by cos. So I'm going to have to split it. Yeah. How do I want to solve this now the easiest way possible? If I square both sides, I'll get cos squared plus, so I'll get 1 plus sine 2x more than 0 if I square both sides, because I'll get cos squared plus sine squared is 1, and then 2 cos sines. Okay, so this is better now. Sine 2x is more than minus 1. So that means 2 sine x cos x is more than minus 1. So that means, maybe I don't want to go that route. Let's find out when it is 0 first. Sine 2x equals minus 1. So that means 2x equals minus pi over 2. And then that's that answer there. So then, well, actually it's 90 degrees, so it's only this time here it's -1. So you could add 2 pi to that. You get 3 pi over 2. Dividing by 2, you get minus pi over 4, or 3 over 4 pi. Okay, yeah, so they're the points where it changes sign then. Yeah, okay. So increasing, decreasing. So if we look at slightly after minus pi over 2, like if we put in like 0 is positive, so this should be the increasing one. Oh, sorry, I meant pi over 4 here. And then decreasing would be then outside this. Now, is that right? Yeah, now it's right. Now it's right. Okay. Oh, wow. That one question took 21 minutes. Man. Man. All right. Well, that's question 237.